All right, in this video we're going to talk about dilations. But first, a brief reminder on how to watch a video properly. So first, pause the video if you need to. Go back if there was something that you missed or it went too fast. Pause when I ask you to pause and do some independent work. Watch the video as many times as you need it. And ask follow-up questions in class should you have them. All right, let's move on. Most importantly, we're hoping that you put together a few things. First, we've been talking about transformations, and just a little reminder about what a transformation is. It's an operation, right? It's an action that maps a pre-image to an image. And a transformation can change the size, the position, or the orientation of a figure. Now, what I want to draw attention to is that these three players right here have done everything to change perhaps the orientation or to change the position. But change in size, the change in size is going to be reserved strictly for dilations. That being said, these three that we've talked about, the reflections, translations, and rotations, all are referred to as a common name called isometries or rigid transformations. So a dilation is not an isometry. It is not a rigid transformation. Think about rigid as being sort of resistant to change. Press pause now and get this entire statement into your notes. So either find a blank space on the page or just a plain notebook piece of paper. Get this information in there because you're going to be responsible for this part of the video as well. So a geometry transformation is either rigid or non-rigid. Another word for rigid is isometry, as we're saying right here. An isometry, such as a rotation, translation, or reflection, these guys right here, does not change the size or the shape of the figure. A dilation is not an isometry since it either shrinks or enlarges a figure. So I guess we're now getting ahead of ourselves in what a dilation is. So make sure that you press pause and get all of this into a permanent portion of your notes. Okay, now that you have that in your notes, let's move on to what a dilation is. So as we said, the dilation was either an enlargement or a reduction of a figure. We are now officially changing sizes. And the scale factor, right? The scale factor is going to indicate how the figure will either enlarge or reduce. That scale factor is going to be known as the letter K. So we reference the scale factor as a letter, and that letter will be referred to as K. And K will be equal to a value. Now, as we look over here on the side of our notes, just sort of take a look over to the figure here. ABC, triangle ABC, this is our pre-image, and A prime, B prime, C prime, that's our image. So we're going from a bigger figure to a smaller figure. So what does that mean for K? Well, this example over here on the left is a reduction. And so what we know about K is that it is less than 1. It's technically less than 1 and greater than 0. So it's a proper fraction. Fractions are back in the picture. And then when K is greater than 1, it's an enlargement. Now when we say K is greater than 1, let's be careful. What if we had an improper fraction like 3/2? 3/2 can be re-expressed as a decimal that's equal to 1.5. So if our K value was 3/2 or 1.5, that would be an enlargement, right? Because the value is greater than 1. So be careful. We're talking about proper fractions, right? Where the top number is smaller than the bottom number. When converted to a decimal, it's 0.75, it's 0.23, it's 0.33, something like that. That's going to be a reduction. Let's go ahead and put this into action. So just like all of the other transformations, I'm going to have an approach on how to handle this. And my approach to this is first is to go look at that value of K. K is equal to 3. So this is an enlargement, right? I know it's an enlargement because 3, the value of 3, is greater than 1, so this is an enlargement. Now what are we going to do? Well, I guess the first thing we should do is plot our points, A, B, C, and D, right? And we're going to make ourselves a rectangle. So go ahead, press pause, and create your rectangle. Okay, so hopefully you have the rectangle ABCD as shown here. And what I've done right here is I've written out my coordinates for A. A was at -3, 0. And because K is a value of 3, it's just a multiplier. So I'm going to take the X and the Y value here, X of -3, Y of 0, and I'm going to multiply both values by 3. And then I'm just going to record the new values. So -3 times 3 is -9. So I'll record that here. And 0 times 3 is 0, so that's that. Then I come over to my grid, and I'm going to plot -9, 0. And 9, 0, -9, 0 is way out over here. So what's happened? I've stretched A out. And now I'm going to do the same for B, C, and D. So B is 1, 2. When I multiply 1 times 3, I get 3. And when I multiply 2 times 3, I get 6. For C, 2, 0. 2 times 3 is 6. 0 times 0 is still 0. And for D, -2 times 3 is -6. And -2 still times 3 is -6. Now I'm going to plot those points, connect the dots, label them appropriately, and I'm all set. And now after pressing pause and catching up with me, what you should notice is that my big blue rectangle is like a big brother version or a big sister version of the little red, oh, I didn't mean to say triangle, rectangle. All right, it's a little late here recording. So I got my rectangle ABC and I got my rectangle A prime, B prime, C prime, D prime. And I knew that this was an enlargement, so it makes sense that after I do my arithmetic over here, that I end up with something bigger. Now, let's try not an enlargement. Well, what else is there? There's a reduction. And what do I notice? K is 1/4, less than 1. So what's going to happen? I'm going to take a moment and I'm going to actually plot the triangle this time. And when I'm done, I'm going to apply the multiplier of 1/4 times all my values and come up with my new coordinates, plot those, and what should I have? A smaller version of the original triangle that I started with. Okay? Why don't you go ahead and first plot your original points. Then we'll tackle the arithmetic. Press pause now. Now, as you should have noticed, this particular triangle is fairly large. And that makes sense because we're going to draw something that's smaller, 1/4 the size as a matter of fact. The other thing that you should be noticing is that our grids for a while were 8 by 8s. This is a 10 to the right, 10 to the left, 10 up, and 10 down. We're now on a 10 by 10 grid, and we're getting these bigger values. So just take heed that if you had been memorizing that the other grids were 8 by 8s, these are now 10 by 10s. All right, let's go for the arithmetic now. Let's start with just our x-coordinate. So I have a -4 as my x-coordinate and a 1/4 multiplier. So 1/4 times -4, well, 4 cancels out the 4 and I'm left with a -1. 1 times -1 is -1. So that's what I'm going to write here. And then 1/4 times 8, 4 goes into 8 2 times, and 1 times 2 is 2. So I have -1, 2 is my W prime. So I come over here and plot that point. And that's my W prime. And now I'm going to do the same for X and Y. What happens when I get to the X coordinate? Well, 1/4 times the 10, 4 goes into 10. Well, it doesn't go in nicely. So you could say, well, hey, 10 divided by 4 is 2.5. But just for the record, 4 and 10 are both reducible by 2, so that's 2 and 5, which is 5/2. But for plotting purposes, it's actually more convenient to go for the decimal. So whatever floats your boat on how you want to handle the arithmetic, but that's going to be 2.5 for the x-coordinate of x prime. And then, of course, 1/4 times times 0, anything times 0 is 0. So 2.50 is going to land us at, just a point in the middle here. And it's okay. We're just going to ballpark it in the middle. We're going to do the same thing for the end here. 1/4 of -2. Right? When we multiply that out, is going to be -2/4 or -1/2. I want that -1/2 like this. Okay, or -0.5 is probably more applicable for graphing purposes. And again, we took 1/4 of 8. We know that that was 2. So 1/4 of -8 then would be -2. And -1/2, -2 is right here. And now I'm going to do is just connect those dots and finish labeling. And now we have the finished product, W prime, X prime, Y prime, and this little blue triangle is a 1/4 replica of the original. If you've ever looked at the back of like a Matchbox car underneath on the chassis, it'll give a scale number. It'll say something like 1/16 replica, which means that all the parts on the Matchbox are 16 times smaller than the original on the vehicle. Just drawn to scale. It's a little sidebar note worthy of mentioning. Let's move on. So we've handled, given a scale, how to enlarge a figure, given a scale, how to reduce a figure. But now we want to figure out how to identify the scale. So here's what I notice. Our pre-image is the smaller trapezoid, and the image is the bigger trapezoid. And so all I want to do is just grab a set of coordinates that are in corresponding positions on both images. So say X and X prime, those are occupying corresponding locations, similar positions, or Y and Y prime. Look for something that's easy. For me, I think that X and X prime are the best going. So I'm just going to go ahead and I'm going to obtain their coordinates. So press pause and identify the coordinates of both X and X prime. Press pause. So I was able to identify X as being at coordinate 2, 0, and X prime as being at 8, 0, 8 to the right. Now the question is, how does one go from 2 to 8? Well, it was an enlargement, and so I'm going to multiply by 4, of course. So K has a value of 4. Now, it's not possible to check the Y value, so let's try to grab a couple of more points just to make sure that we're absolutely firm about this idea. How about Z and Z prime? What are their coordinates? Press pause and obtain those. So I got values of -1, -1 for Z, -4, -4 for Z prime. And again, how do I go from -1 to -4? I grow by a multiplier of 4. How do I go from -1 to -4 here? Well, obviously the same thing. So we're still at a K value of 4. Now all you need to do is simply grab the coordinates of an initial point, right? Its pre-image point and its image, and then I just decide how do you go from the smaller number to the bigger number, and think about that as the multiplier. Now if we had gone from, say, W prime this way, if this had been the original pre-image and this was the image, then still I just look at the multiplier of 4, but because in the reverse direction it would be a reduction, instead of 4 I would say it's 1/4. But the first thing I identify is that denominator. We'll try to keep things simple for you and try to stay off the 7/2 K factor or something like that. Try to keep it simple. All right, so that's about it. Now you're onward and upward to answering a bunch of these on your own. Just a word to the wise, if you're still listening to me, if you hang on a second, on the next page, I will give you the answers to a couple of problems that you could check as you work on your own. Good luck. As promised, for the loyal listeners, here are the answers to number 3 and number 8. But don't just copy them down. You're going to have to deal with 1/2 and 1/4 in your on your next assessment, right? For homework and for tests and quizzes, you're going to have to handle fractions. But because I know they tend to give you a little bit of a trip up, what I wanted to do is allow you to have the solutions that you could check against your work. But if all you're doing is copying this, right, and using it as your work, well then, yeah, I guess we won't catch it on the homework grade, but you'll definitely trip over that on an assessment. So don't just copy them. Make sure you know why these are the coordinates. All right? Thanks for hanging in there, and hopefully this was helpful. Take care.